let's move on to the subject matter of today. And what is that? That's something I call the universal movie. And let me show you why we had to create this tool. It's a tool, okay? And let me show you why. Here we have one fellow, and he says the following. He says, there's no such physical presence as a cross-section of time. I showed the other day that, like for states of matter versus phases of matter, I'm saying that we have to get a cross-section of time, such as the state, which is a static concept, versus a phase, which is something in motion. You need 2 frames of the film to create a phase. You need only 1 for a state. And so these people have problems with that because suddenly, I'm stopping the universe, and they say, well, you can't stop time. Yeah, no kidding. You can't stop motion. We're making believe that we can stop time. Like make believe. It's a thought experiment. Okay, so he says there's no such thing as cross-section of time, meaning you can't stop time. Everything's always in motion. Well, you didn't have to tell us that. We all know this. Okay, we all are aware that motion is perpetual. Okay, in both directions of time. Okay? But all physical presence is in motion always. Fundamentally, time is this constant changing locations. There's no pictures frame. The single frame in the universal movie. Another fellow says the following, says, Bill, all wrong about definition of state of matter. State, remember, static concept, right? By state of matter or state of aggregation of molecules, which I guess is not the same thing. Aggregation is not the same as a state. We mean, but he doesn't understand that, okay? We mean a conventional classification of the states that matter can assume depending on what? The mechanical properties it manifests. Yeah, but see, the mechanical properties it manifests is called motion. That's what you just talked about. That's what you just defined. You defined motion. So you're saying that a state is motion. That's what you said. But of course, he doesn't do this kind of analysis because they think it's word salad. They say, no, I didn't come here to do grammar. I came here to do physics. And so they get tripped because they don't do an analysis of the language. And all they do is copy paste. They look at the history of the word and they put it in there and they say, well, this is what it's always meant. This is what people around the world think of it. We don't care. Here we analyze the word, and if it's irrational because it was defined irrationally by our forefathers, people hundreds of years ago, then we correct it. We fix that which is broken. And he said, why is it important to classify the state of matter? To destroy your religion. That's why we need to classify. That's why we need to define these terms. We need to know what we're talking about. And when you talk about state, unless you understand that state is a static concept and that everyone in mathematics treats it as a phase, as a dynamic concept, they don't realize they have a contradiction. And all these people, they just go out there and say, but look at what I found out there in the dictionary, in the encyclopedia. This is what the mathematicians say. We don't care about any of that. We clean our nose holes with all that. We analyze the word. If there's a problem with the word, we clarify what's wrong with it. And if there is something wrong with it, then we fix it. Okay? That's the way it works. Okay, and then finally we have another fellow, and he said the following. He says, it's all word salad, He says, who the hell cares about this word salad anyway? Plasma will remain the fourth state of matter. Yeah, all these ignoramuses, they just want to continue using the word plasma. They want to use the word ether. They want to use the word wave. And when you say, look, let me tell you what the word wave really stands for. It's a verb, not a noun. They say, well, that's word salad. I didn't come here to do word salad or word analysis. I came here to do physics. And they're using all these words as nouns. And no, not a single one of them is a noun. And for that, I had to create this tool called the universal movie. Okay, so let's look at the universal movie. Let's see what it's all about. Here's the universal movie. Okay, and it's relatively simple. If we look at a single frame of the universal movie, and we think of the universal movie as simply the distance between every object in the universe at a cross-section of time or cross-section of motion. It's really, see, this fellow said earlier, he said, There's no such thing as a cross section of time, because time involves an interval, and you would think that time requires at least 2 frames of the movie. Of course, that's true. You need 2 frames of the movie for motion, and you need 2 frames of the movie at least for time. Okay, so he says you can't have a single frame because that would not be time. And I don't know if that's what he meant, but that is correct. If you have a single frame, you don't have either motion or time. What do you have? And that's what this notion, this tool called the universal movie is for. It says, let's look at a single frame of the universal movie. We see, like if we stop the universe, and in there, all you will see is objects. That means every atom in the universe, every electron, every sub-electron, every microelectron, everything is stopped. Nothing moves. We have only static concepts in there. We have distance, which is separation between objects. We have location, and we have existence. There is no motion. There is no such thing as time. For time and motion, we need at least 2 frames of the movie, of the universal movie. Here we're talking about a single frame, okay? So what is it that we're actually doing here? Well, we're telling God, you know, Almighty God, all-powerful God, all-knowing God, we're telling him, look, stop the universe, because these people have a runaway mind. And, you know, you want to say, look, before you move anything, let's identify the objects. See, all these people start their theories, their movies, they start them with a film strip. They start them in motion already. You say, no, I want to see the first frame in your movie. I didn't get to see that. And they're already putting things in there that are already in motion. So they already start the movie with a film strip. So we tell God, please, we pray and say, God, please stop the universe. Because these people are, you know, have runaway minds. Their heads are in motion, like this. Quite a bit in motion, okay? And so God goes in there and he stops the universe at a single frame. He chose, in this case, frame number 32. He stops the clock, okay? The heavenly clock, I guess. And yeah, God moves and everything moves in heaven, but I guess you could say he's in a different dimension, right? So what we're going to look at is a frame of our universal movie. In that frame, nothing moves, okay? And for this, we have to determine what do we find in that frame. If nothing moves in the universe, what is in there? What is in that universe? That's what we're going to try to figure out. And yeah, for this, we're going to have to look at what I call the foundations of physics, okay? Because we need to identify the main things that we need to do physics. I mean, what kind of things do we want to understand as far as a mechanism, as far as how the universe works? Well, we figured out all the visible stuff. You know, you see, I don't know, a donkey pulling a cart, and someone asks, well, how did the cart move from A to B? He says, it's very simple. Let me show you the movie. And the movie shows, you know, a donkey tied to the cart, pulling the cart, and says, see, it was at A, and now the cart is at B, and then the owner unhitched, you know, the donkey, and there's the cart. So that's how the cart moved from A to B, because everything is visible. That's why. It's so easy, because we can see everything. We can see the movie, we can watch it, no problem. But now we see Bill Gates' famous experiment, you know, we see a pencil falling. And you say, why did that fall to the floor? Why didn't it fall to the ceiling? Because we do it again. Let's do it again, okay? We let go, and there it goes. It falls downwards. And never does it fall upwards. And you say, well, here I didn't see the mechanism. I don't know the cause. Why did it fall down? Is something pushing the pencil from above and something pulling on the pencil from below? And I don't think there's any other possibility. I mean, it's either push or pull. Those are the only 2 forces in the universe, okay, that we can imagine. Not like in quantum where they have 4 forces. Okay, so yeah, they've invented 4 forces in quantum. 2 of them are pull and 2 of them are push. You know, so I don't know what they really invented there, but there's only 2 forces, push and pull. And the question is something pushing on the pencils or is something pulling on it? That's it. But we can't see it. So we don't know if something is pushing or something is pulling. And that's what we're trying to figure out. We're trying to figure out the mechanism. What is causing the pencil to fall? And of course, we're going to have to do a lot of thinking here, because there's no way you can run an experiment and determine what invisible, intangible object is coming in contact with the skin of the pencil to either push it or pull it downwards. That's the whole issue. And that's just one example. The other one would be magnetism. How does a magnet attract another? Same thing. How does it do it from a distance when you cannot see whatever's pushing or pulling the magnets together? So that's where you have to fill in the blanks with a thought experiment. Say, well, what if? What if we put something there and find out how Mother Nature could be doing this magic trick that we can't figure out through see and touch? Okay, so we go down to the foundations of physics. Okay, and these are the foundations. First, we need to know what science is. Science is rational explanations. It's got two branches. One is physics, the other one is philosophy. Those are the two branches, and there ain't a third one. Okay, so everything falls under one of those two. Physics studies rational, or not studies, but is in the process, the discipline, right? Is in rationally explaining what causes and mechanisms. That's what physics is about. Physics is not about math. Physics is not about running experiments or doing predictions or anything like that, doing observation, gawking and not understanding. Physics is about explaining. What are you explaining? You're explaining causes and mechanisms. Hopefully you do it rationally. Otherwise, you're doing religion. Okay, and so we start with the golden principle. You can't do physics without an object. You need objects to do physics. If there were absolutely nothing in the universe, completely empty space, what's happening? What's going on? What are you observing? What experiment would you run to begin with? For those who believe in experiments, what are you seeing? Now you need objects to have mechanisms, and that's what we're going to try to explain, how those mechanisms work at the universal level as well as at the micro level. And so those are the words that you need to define up front, because these are all static concepts. Okay, there are still dynamic ones such as motion, and you also have concepts. Words such as concept. You need to define those as well. But right now we're going to stick to the static ones, because remember, we're going to look at a single frame of the universal movie. Okay, and so here we have it. Something. We need to know what something is. What does the word something mean? And it's the opposite of nothing. Either you have something or you have nothing. They are antonyms. Hopefully one is the opposite of the other, and now we can use them consistently as long as we define them properly. And we define something as that which has shape and nothing as that which doesn't have shape. So we have good definitions. We can use them consistently for the purposes of physics. Okay? We call the something also object, and we call the nothing also space. Those are the words we're going to use. Then we have distance, separation between two objects. We call that separation distance. It's not a measurement. It's not involves numbers or units. It's simply qualitative separation. Okay? Because Mother Nature, Father Universe, they don't do measurements. All they say is this atom is over here and that atom's over there, and there's separation between them, certain distance, certain gap. Location, the set of distances. You want to know where any little atom, any electron in the universe is, you just take the static distances. Again, the separations to all other objects, that is the qualitative location of that object with respect to all others. Okay? And you can take any subset of that and do the same thing. Okay? And then exist, well, it's an object, something that has location. Very simple. So those are the main things. Now you have a foundation with which to build your theories of physics. What is physics? Causes and mechanisms. Now you can explain causes and mechanisms once you define these terms. That's the way it works. Now we have a rational foundation on which to build our theories of physics. Okay? What are we going to try to figure out? We're going to try to figure out stuff like magnetism and gravity, which are intangible. The mediators are invisible and intangible. Therefore, we cannot run an experiment, make any predictions, make any observation. None of the stuff that mathematics uses. We can't use any of that in physics. In physics, we have to do thought experiments, and the way we do the thought experiments is by introducing objects in those spaces, right, to find out how Mother Nature could be doing attraction or pushing or whatever it's doing. Okay, so that's what we do with this. Here's the other same thing, but in you could say in pictorial form. We have an object there, a cat. It's got a separation from another object called a dog, and as a contrast, they have what is called nothing, that which has no shape. Okay, I put a shape there which is squarish. or rectangular-ish, but that's because, you know, I had to put a stop to my frame, only because of that. But nothing has no shape, therefore there is no boundary to nothing. And what do we have between the cat and the dog? Well, we have distance. It's known also as separation, gap, chasm, if you want to call it, whatever. Okay, there's a separation there. And then we move to the other static group of static concepts, location, which is a set of distances between the cat and maybe a tree and a chair or whatever. And as long as that cat has location, we say that the cat exists. Okay, the cat that I'm thinking of in my brain, that one doesn't exist because it doesn't have location to begin with. Okay, so the abstract cats that we have, like the one you drew on the paper, the ink and the pen have location, but not the cat. Okay, and then again, all of this is countered, or you could say it's contrasted by nothing. Okay, so this is the notion. This is the foundation on which we are going to start. And yeah, if we're going to isolate a single frame of the universal movie, all we're going to see in that frame are static concepts. Objects, distance, distances, plural, locations, and existence. That's all you have in a frame for the purposes of physics. Okay, and so here we have an example. Okay, we're going to go through some example here to get the hang of it, because a lot of these people with wandering minds, they cannot keep up with this, unfortunately for them, right? And here's a chair. Okay, we can put it in a single frame of the movie. We call that a solid. Okay, do we call it a solid because it's got a lot of atoms, or, you know, mereology? No, we call it a solid because it's solid. It's not moving. No, we call it a solid because it has length, width, and height, just like almost any existing object, and it's and we can see it in a single frame. Okay? It doesn't move. You don't have to, to see an object such as a chair, it does not have to move. You do not have to move it. Now, once you've identified the object, and now you identify it for the ET and say, look, that's a chair. You point to it and call it chair. Now he learned your language. He knows what that object is in your language. It's called a chair. And now you can do whatever you want with it. You can move it around, like you see there at the bottom. You can tell your theory of what happened with a chair, right? But you can point to the chair in one frame of the film. Why? Because you're just going to name it. You're going to give that thing that's in front of you a name. And you're going to categorize it as a solid. Okay, here's another one. Okay, this is a liquid, in this case milk. And again, you can point to milk, okay, and say, look, that's a liquid. It falls under a category of liquid. And milk, I can point to it with one finger and call it milk. It doesn't have to be rolling like you see at the bottom. It doesn't have to be dripping. I can point to milk, a puddle on the floor, and call it milk. Okay, it doesn't have to be moving in order for it to be milk, because milk is not defined as something that is moving, yet it forms part of the categories called liquid. Once you identify milk, then you can put it in your theory and say, well, it's dripping, and whatever you're going to do with the milk in your theory. So you can have it moving later on, but milk, to point to it and identify it, you do not have to under any circumstances have it rolling, dripping, or moving in any way. You can just point and tell the ET milk, and he learned the word milk. Does the word milk involve any motion? Absolutely not. Okay, it's a liquid. No liquid involves, the definition of the word liquid does not involve motion. I can point to any liquid in a static frame. It doesn't have to be moving and say, that's a liquid. Just like that. It doesn't have to be rolling, dripping, moving, nothing. Here's another one known as gas. It's one type of gas. It's called vapor, okay? And I can point to vapor in a snapshot and say, look, that's vapor. And I identified the word, okay, vapor. The word vapor does not include any motion whatsoever. I can point to that single frame, in that first frame, frame number one, and say vapor, and the ET understands that that cloud of whatever that is belongs to the category of vapors. I do not have to have it moving like you see below. I can later on have it moving if I want for my theory, but I don't need to have it moving up front to begin with. I just point and call it vapor, okay? And in fact, here's a picture of vapor in everyday life. Someone took a picture and that's what it looks like. Okay, so yeah, you can have vapor in a single frame of the film. I point and say vapor, and nobody's gonna say, Bill, it's not moving. Yeah, no kidding, because the word vapor does not include any provision for motion, and that's what these people do not understand. They think, let's talk physics. No, no. First, we got to talk language because you don't understand language. Before we can get to physics, we need to understand the language. Okay? Okay, but let's look at some words that are famous out there, especially among dissidents, but also in the establishment. And here's the first one. It's the word ether. Okay? Ether is always moving. So these people say, look, I'm going to put ether in frame number one. I'm going to point to it and I'll call it ether. Well, you can't do that because ether is always moving. Ether is many particles, okay? You can't point to it because you have to watch it. And right there, I put it all in one frame, but you have to think of that as something in motion. Therefore, you're already looking at a film, which they put in a single frame of the movie. And that's irrational. That's surrealistic. Okay? And then, yeah, they say, look, light is the waving of the ether. What do you mean waving of the ether? The ether was already waving in or moving in frame number one. You put a film inside a movie, inside a frame of the movie, a single frame of the movie. That's where the error is. And they don't understand that. They don't understand that ether is already in motion. In fact, it's many particles. And that's called mereology. And mereology is irrational. It's used in what they call philosophy, which ain't philosophy either. Okay, it's just people who never identified what philosophy is, and they say, oh, I do philosophy. And ether is some kind of mereology, many things in one frame. You know, that's unphysical. In physics, we do not use such concepts as mereology, meaning that a table is really all the atoms that comprise it. An elephant is all the atoms that comprise it. No, no, that's not an elephant. Elephant is what I pointed to, not all the atoms that make up an elephant. And that's the situation with ether. Now, a lot of people say, Bill, you don't know what the ether is. That's the first thing they say. They never tell me what the ether is. They tell me what the ether ain't. And it ain't what I said, many particles. Well, they have two choices, only two. They can either put a picture of the ether or anywhere on the internet and say, look, this is the ether. And I do challenge you or warn you, really caution you. Don't look it up on Google images. You'll get 100 different versions of what people have for the notion of ether because they never define what the ether is. No one has any idea, especially those who propose ether. They have in their tiny little minds, you know, what they think the ether is. So they never got in there and really analyzed the ether in any detail. Now, the ether, since the days of the Greeks all the way to today, has always been many particles. And that's the notion they had. They say the ether, the many particles, fills space. It's a substance that fills space. They're all vibrating, and we call that vibration light. That was the notion that we had at least since the days of Huygens and Robert Hooke, who came up with the notion that light is some sort of wave. And we've had that for 400 years now. And so the ether is many particles, and they're always in motion. If you don't like it, if you say that's not the ether, Bill, no problem. Tell me what the ether is. By that, you have to put a picture or point to a picture somewhere on the internet. You know, put a link and say, look, at this link, you'll find the ether. What I say is the ether. Okay, good. But if you define the ether and you say, look, I looked it up on the Wikipedia or some kind of encyclopedia or the dictionary or some mathematician out there, and he says, this is what the ether is. If you can define the ether, it's not a physical object. Objects we point to, concepts we define. So you had better not define the word ether. Okay? Because otherwise we can't use it in physics as a physical object. Objects are only those you can point to, and they have to have an image, they have to have shape, and we don't care what it's made out of, so we don't need to see all the little things that makes up the thing that you call ether. It's got to be a single piece. That's the way we present objects in physics. You point to a table, you don't say, well, it's made of all these parts, got a leg, and no. We treat it as if it's made out of a single piece. You point to the elephant, it's like if the elephant is made out of a single piece. The word elephant represents the whole thing and not little pieces and say, well, this is the tail of the elephant, these are the legs, this is the trunk. No. That's an elephant, what I pointed to, the whole thing, as if it were a single piece, made of a single piece. So mereology does not participate in physics. That's in religion. Okay, so don't tell me what it's made out of and it's got a lot of particles and so on. The ether had better be something made of a single piece that's got shape and I can point to. If you can't do it that way, it's not a physical object. Otherwise, you have to define what an object is. You got to start there first. What, word salad? Yeah, let's do some word salad, okay? Here's another famous word, especially used by dissidents, electric universe. They call this plasma. They have these bees buzzing around. They call that plasma. And as you can see, first frame is already moving. You say, well, hold it. What do you mean it's moving? I wanted to see it standing still. Well, the problem is you cannot see plasma standing still because if it's moving around and every atom or most of those atoms are ionized, some are recovering their electrons, some are losing their electrons, other are neutral. They have not yet either gained or lost an electron. And that whole soup is known as plasma, and it's something in motion. You cannot put plasma in a single frame like I did there and say that's plasma. No, plasma requires two or more frames of the universal movie. So you cannot put plasma in a single frame. Otherwise, it's not only irrational, it's surrealistic. What you're doing is putting film in a picture. That's what you've done there. Okay. Here we have another famous word especially of the electric universe. It's called electricity. And they say it's the movement of electron beads from one atom to the next, and that's called electricity. And they say, I'm going to do this with electricity. I'm going to move electricity this way, and I'm going to move it that way. One fellow says, it's, lightning has shape. Because he says, I took a picture of lightning and it's got shape. Well, you didn't take a picture of lightning, because if lightning is electricity and electricity is the motion of particles, you cannot take a picture of electricity. Electricity is something in motion, which is what you see there. And if you took a picture of something that you that you call electricity, the picture does not represent electricity. That's only in your head. Okay, electricity is defined as something in motion, and so you cannot put electricity in a single frame of the movie, of the universal movie. That's not electricity. Whatever you took a picture of, whether it's plasma or electricity, it ain't plasma and it ain't electricity. You got that? Okay, I hope so. Okay, here's another famous word. This one's used quite a bit by the establishment. It's known as the word field. They have this thing which they say stretches all the way to the edge of space-time, wherever that ends, and they always have it vibrating. And it's defined essentially as many values in space. So field is just a bunch of values with units, numbers with units. And then they have it moving. They say it's vibrating. It's an excited field. So again, they start with a movie, and they put that movie in a single frame of the film. And that's irrational. And a couple more, just to rub it in. This is Big Bang. And here the problem is that they never started frame number one. They already have it exploding. So they put a little dot, and you say, well, how did that dot get there? I mean, hopefully, there was a movement from frame number one to frame number two. And no, they always start at the explosion. or that the dot was already there. We don't have the first frame where God puts that little dot in there called the singularity. They say, well, we don't know what happened frame number one. Well, how did it get there? I mean, if we're going to talk about the origin of matter, the origin of the universe, hopefully you tell us how that little dot came into being, right? Was it God, like the religious folks say, traditional religious folk? And finally, another one, the last one here, we have a black hole. Okay, and the black hole also is defined as a star that is collapsing upon itself. Okay, and they talk about escape velocity. Okay, that not even light cannot escape. And so they have all these concepts, dynamic concepts of a black hole, where they all involve motion, whether it's the star collapsing because of its gravitational attraction to itself, to its center, or because they talk about the escape velocity. All these are dynamic concepts. That's how they start their presentation. And then they say, well, the black hole does this and the black hole does that. No, you can't do that. You can't talk in those terms because you haven't presented a static object. You have to stop the universe in order to be able to talk about the objects. You have to stop the universal movie, like we showed earlier, with God, stopping time, so that these people don't have these runaway minds that, go around in circles. Okay, so these are the reasons, summary here, of why you cannot include any of these words in physics as a noun. In ordinary speech, you can call it a noun, not in physics. Physics, only objects can be nouns. And so the ether, these are the definitions you'll find out there. The material that fills the region of the universe beyond the terrestrial sphere. If it fills the universe in its many particles, then it ain't an object. We don't care about meteorology or about motion. Plasma, it's ionized gas. So you can't do anything with plasma because plasma is not a thing. Plasma is a thing in motion, and you're going to put it in motion. You can't because it's already in motion. Electricity, phenomena associated with the presence and what? Motion of matter. Electricity is already in motion. Lightning, which is electricity, is already in motion. If you take a snapshot of either plasma or electricity, you don't get either plasma or electricity because plasma and electricity are defined as moving things. Okay, so whatever you took a picture of, it ain't plasma and it ain't electricity. Field, a quantity that has a value for each point in space and time. Again, meteorology, they put all these values and they say that's a field. Now, that ain't a field for the purposes of physics. You can't use that as a physical object and say the field moved the wall. You can't do that, not in physics. It's irrational. And, either I'm going drunk and seeming blurry, or I lost focus there. Okay, you have Big Bang, a theory that describes how the universe expanded. So a Big Bang is already an expanding theory. It's already in motion. So you can't talk about Big Bang as a thing. Okay? And again, we're referring to the singularity of the Big Bang because that's where it all starts. And again, if it's already in motion, it's already expanding. If you start at frame number 2, as the mathematicians always do, they never start at frame number 1. They don't know how that singularity, which is a concept anyways, got there. You can't use that singularity and say, this is the Big Bang, this is where it all started. In fact, the word bang suggests explosion. Explosion, I think, was something in motion. When you say a hand grenade exploded, you're not talking about the hand grenade, you're talking about what it did, explode. And if you bang the big, well, then you're talking about motion. And then finally, the black hole, a region of space-time where gravity is strong. Gravity is something in motion, okay? Because you talk about a region, you're not talking about a single point, okay? But even if you were talking about a single point, what are you saying? You're saying that's not the black hole. The black hole is what it's doing to everything around it, which is pulling it in, okay? It's just saying, look, there's a lot of gravity there for whatever reason. And again, it's defined as nothing, including light, can escape it. So again, they talk about escaping. You can't use any of those in the universal movie. Universal movie, every frame in it only has location, static concepts such as distance, location, and existence. Those are the only concepts that you can use in a single frame of the movie for the purposes of physics. And of course, that eliminates all these words that dissidents and mainstream use alike, like ether and field and plasma and whatever. So that is the roundup. Now you know why that tool is so powerful, because it eliminates all these people with runaway minds that they cannot conceptualize a single frame of the movie, nothing moving, just every object in the universe separated from all others in a static picture, static image, because that's the only way you're going to identify the objects that you're going to use in your theory. If you have everything already moving, like an ether or field or electricity or plasma, well, then you started your theory with a film strip, not with a single frame. That's where you stand.